Welcome to Electromechanical Energy Project. We will discuss three main topics. First, summary of electromechanical singly excited system. Secondly, illustrating our idea. Last, the prototype and how to make our idea more economic. There are plenty of applications on EMEC. Let's consider one main application, a linear actuator. On hearing this word, a lot of questions come up. What is a linear actuator? Briefly, a linear actuator is a coil mounted around a hard core. Now, what is energy balance? It's the amount of energy entering the system is same as leaving the system. As we can see, this is an example of a system with no motion. So by neglecting the losses we will get this relation. By using a simple substitution we will get the power balance equation. By doing more analysis we will find this equations. We will assume the system is lossless. Here, this graph shows us the variation between time and current. What about the power versus time? We will find that power changes non-linearly with time. We will study more complicated system. A. System with motion. Briefly, current will pass generating a magnetic field in the coil which makes the iron part moves. In this graph, we will discuss the variation of flux linkage with current. So lambda is function of displacement and current. We can conclude from these relations. Here we have inductance versus distance plunger. Now we reach the main part, our idea. We all heard the term smart home and how this term invaded our lives, but how can we use a simple electromechanical system like a solenoid to participate in this invasion? We will tell how, but let me start with a simple question. How many times you went out and in the middle of the road, you suddenly realized that you left the windows opened? Yeah, that's a bad situation. We all have been there, my friend. Don't worry, we have a solution. Using simple solenoid and a motion sensor we can make them communicate with each other for your luxury. We can use a simple motion sensor to detect you leaving your home, generating a signal to the microcontroller implemented at your house to switch on the linear actuator circuit, producing a current leading to a magnetic field which attracts the plunger of the linear actuator and close your window. How simple is that? So goodbye old and goodbye burglar. Keeping you secure is our job. Finally, our prototype, which unfortunately is not sufficient due to lack of resources. This prototype illustrates the movement of the linear actuator in the door or the